I'm Alex.
I'm Harper.
I'm Olivia, and this is our Candiomatic 5000. So it works by when you press the pressure sensor, it dispenses the candy. Here's the back. We have the LED light and the pressure sensor connected to one microbit and the servo to another. When the pressure sensor senses a high enough pressure, it sends a radio signal to the other microbit that then moves the servo, and the first microbit turns on the LED light. So this is an action from the back. So this is our wiring.
Yeah. Demonstrate one more time. Okay, one more time.
Okay, so this is how we designed and built the Candiomatic 5000. Get ready for some cringy transitions, y'all.
The problem we're tasked with completing is that everybody needs easy access to candy, and reaching into a bag just isn't that. It's important to solve because everybody has the right to easy access candy and needs the most creative way to do it. Our clients are anybody who enjoys candy, so everybody and needs a more fun and interesting way to eat it. The design requirements were that I had to use a sensor to be activated, have to have a light to indicate that it's been activated, and use a motor to dispense objects.
So this is Harper's generating concept slide, and basically her design idea was that there would be one input, which was the pressure sensor, and then two outputs, which are the LED lights and the servo. Yeah. And it was basically so that you would put the candy in, and then you would press the pressure sensor, and the candy would come out using the servo.
My design idea was that the servo, which is indicated in green, the LED light in blue, and the pressure sensor in black would be connected to a microbit. When the pressure sensor sensed high enough pressure, it would activate the servo, which would spin either 90 or 180 degrees, and the LED light would turn on. And once the pressure sensor wouldn't sense the high enough pressure anymore, it would move the servo back in place, and the LED light would turn on.
This is mine. It's obviously not the best ever, but like, so basically you put the candy in, and then like the turny thing right there turns, and then it goes down the ramp to dispense the candy. So. Okay, so this is our decision matrix, and basically what a decision matrix is a bunch of people like put their ideas and how it will solve the problem into a table, and then everybody like kind of votes on what the best idea is, and it's a good way to organize people's ideas and pick like a compromise for it. And yeah, so you can see how go on. Okay, so this is what we decided on for our design idea. So basically we chose to develop this design idea because it used all the things that we needed, like the LED, the pressure sensor, and the servo, which meets all the requirements, and it solves our problems. The LED is an output, and its purpose is to turn on whenever the pressure sensor is pressed, signaling to the person pressing it that the candy is coming out, kind of like an on switch, I guess. And then the pressure sensor is an input, and its purpose is to send this signal to the servo to turn when the pressure sensor is being pressed. Okay, so basically this is our flowchart. A flowchart is kind of like putting what our code is going to be into words. So as you can see, first the microbit turns on, then is the pressure sensor pressed? If it is, then that means that it's going to go down, the LED light's going to turn on, and the servo is going to turn.
And if we're building and testing a prototype for the wiring, after testing it out, we realized that there was a problem with the pressure sensor. After some troubleshooting, we figured out that the main problem was with the wiring. So we had to move one of the alligator clips from G&D to 3V, which completely fixed the problem. For the coding, we had very minimal changes. Microbit E, which was the microbit connected to the servo, the only change we made that it was going to display Candiomatic 5000, which was based on our original design for the machine, but it never ended up being used. And for microbit D, which was connected to the LED and the pressure sensor, the change was that we had it display the value of the pressure being sensed, which helped us out with the troubleshooting and any problems that we might have in the future with our project and to see if the pressure sensor was at fault.
Okay, so this ended up being our final prototype. You guys saw it in action, but to recap, basically it works by pressing the pressure sensor. It sends a radio signal to the microbit, which sends a signal to the servo, and the servo moves to release the candy. When the pressure sensor is pressed, it also turns on the LED light in the front of the machine. You can see it working.
For reflection evaluation, our device turned out pretty much how we wanted to, except for some minor design ideas and that it didn't look as clean maybe as we wanted it to. Our team faced some problems with the cardboard and the wiring. The wiring was a pretty simple problem that we were to fix, but the cardboard, that the candy wouldn't move down the slope properly or dispense well enough, and that the cardboard would fall off of the servo. But we fixed this problem with the hot glue and just doing more cutting and taping. Some developments that we would like to make in the future is that to have more control over the candy, what type of candy is dispensed, how much of it, and just overall that. And I think our team learns mainly how to troubleshoot and how to turn our code and wiring into a final project. Thank you.
All right, let's give them a round of applause.